We have 2 lessons left. This is the second last lesson. Your test will be Wednesday or Thursday next week. Mutually exclusive. When 2 events are mutually exclusive, they are disjoint sets. They have no common elements. So if something is mutually exclusive, there's no common elements between the two. So if I said hearts and spades, they're completely different, correct? So they would be disjoint. But if I said hearts and threes, would they be mutually exclusive? No, because there is a 3 of hearts. So that's a problem. There's overlap, okay? So mutually exclusive means no elements in common, and it's a disjoint set. So this here would be sets A and B are part of the universal set. A and B are disjoint, or they're mutually exclusive. So if you can say that there's no overlap, they're mutually exclusive. If there's overlap, they're not mutually exclusive, okay? On your formula sheet over here, you have the probability ones. These are the 4 probability formulas we're given, okay? Or means mutually exclusive or not mutually exclusive, okay? That's what the or symbol means. So these are ors, the very top 2. If they're mutually exclusive, there's no overlap, correct? So this one up here is mutually exclusive. This one down here is not mutually exclusive. Why? Well, this one here says P of A plus B of B gets me P of A or B, correct? So if I just take all the elements in A and all the elements in B, I get all the elements in A or B. We agree? This one is not mutually exclusive because if I take all the elements in A and all the elements in B, I have overlap. So what am I doing then? I'm counting an element, possibly 1 or 2 or 3 or a whole bunch of elements more than once. Okay? So what does that mean? If A was like 1, 2, 3, and B was like 2, 3, 4. If I said A or B, P of A plus P of B, it'd be 1, 2, 3, 4, 5, 6. So I'd say the answer is 6. Is that true? Is there 6 elements in A or B? No. There's 3 here, 3 here, so that would be 6 and 6 elements. And then I'd have to subtract off what? 1, 2 of them because there's 2 in both. I counted it twice, right? Can I count something twice? No, so I'd have to subtract it off. Okay? So not mutually exclusive means that they're not mutually exclusive of each other. There's overlap. Mutually exclusive means there's no overlap. I'm just using these as elements. It works the same for elements, although these are probabilities, right? Probability would be something over something. Okay? So this is the mutually exclusive formula. No overlap. It's the top formula on your formula sheet. And the not mutually exclusive, overlap. The good thing is they're in alphabetical order. Would they be? Mutually exclusive, not mutually exclusive. M, then N, right? They're in alphabetical order. Mutually exclusive, not mutually exclusive. Okay? Mutually, not mutually. M, N. All right? So let's go through example 1 so this makes sense. The probability of Brenda getting a hit in baseball is 0.345. So every time she goes up there, she has a 34.5% chance of hitting the ball. And you might be like, well, that's really crappy. Yeah, but most of the time baseball is like, if you can get to a 0.5 average, you're doing pretty awesome. That's every 1 in 2. That's major leagues, very rare. Okay, so the probability of Brenda getting a hit is 0.345. So we're going to write it out, probability of Brenda hitting, right? The probability of Brenda or Deborah getting a hit is 0.617. So we're just writing down the information that's given, right? Then it says the probability of both Brenda and Deborah getting a hit, Brenda and Deborah, is 0.224. So if I went to do a Venn diagram, no overlap would mean that the and would be empty, correct? If I did a Venn diagram and I drew my 2 circles, they would be completely separate from each other if they were mutually exclusive, which would mean that there would be no overlap, no ands, correct? The moment I give you an and, what are you going to tell me this question is? Not mutually exclusive. Why? Because there's overlap between Brenda and Deborah. I would have to, if I drew this as a Venn diagram, I would have to draw it with an overlapping circle. Okay? So let's see what happens. We'll do it two ways. We'll do it with the Venn diagram first. So we have Brenda, Deborah getting a hit. Now, these are all decimals. What do probabilities add up to when they're decimals? 1. When they're percents, what do they add up to? 100, and they should in a Venn diagram as well. Okay? So, in the overlap, we have 0.224. Why did I have to start off with the overlap first? Yeah. Right. So you have to start off with that middle because the outside just Brenda also encompasses that as well, right? Okay, we have overlap, so it's not mutually exclusive. And we need to be able to tell the difference between mutually exclusive and not, first off, because they could just give us, and I could, a test question that just gives you scenarios and asks you if they're mutually exclusive or not mutually exclusive. So if you can't tell them apart, that's a problem. Just like I can give you a scenario that asks you if it's a perm or a com, right? Okay. The next thing we go to, we can't go to the ors because we'd have 2 empty spots, correct? But we can go to Brenda. So how are we going to figure that out? The probability of Brenda is 0.345. So the entire circle is 0.345. We agree? So we have to subtract off 0.224 to get just what's in just Brenda. Only Brenda only. So what would you get? Pardon? Now what can we do next? We can do the OR. So 0.121 plus 0.0224, which is 0.345, and subtract off 0. Or from 10. Subtract that from 0.617. What do you get? What do we always have to remember with Venn diagrams? It's outside the circles, right? We always have to check, is there stuff that's outside the circles? Okay? So we know that if it's decimals, they add up to 1. So what's 1 minus 0.617? Because that's technically what the circles add up to. 0.3, what did you say? So what's the probability of Deborah getting a hit? That's Deborah getting a hit only. What's the probability of Deborah getting a hit? 0.272 plus 0.224. What do you get? So that's what we're thinking it is, right? So we're going to try with the formula. We know because there's overlap, which formula are we using? Not mutually exclusive. So we rewrite our not mutually exclusive formula. And we can use this formula as long as we're only missing one thing. So we have A or B equals the probability of A plus the probability of B minus the overlap. Let's see if we get the same answer. We know everything but the probability of D. Now, instead of writing B's, what could I have wrote? D's. So we could have probability of B or D, and then just replace them. A's become B's, B's become D's, or you could keep the B's to the B's. Doesn't really matter, right? Probability of B plus probability of D minus the probability of A, or B and D, sorry. So let's fill in what we do know. We know the probability of A or D. It's 0.617. What's the probability of B? 0.345. Probability of D is what we're finding, right? Minus the overlap. Now we solve it just like a linear system. We can put the 0.345 and we can subtract the 0.224, so we get like terms together. So we get 0.617 equals P of D plus what? What's 0.345 minus 0.224? 121? We agree? And then how do we get P of D by itself? Just normal solving like you guys did in grade 9. Minus 0.121. So P of D equals 0.496. Exact same answer. Is either way better? No. Could some of you do one way and some of you do the other way? Yeah, it doesn't matter. When you're done, flip it over. Okay. A spinner number 1 to 10 is spun. Each number is equally likely to be spun. What is the probability of spinning? Equally likely just means that each of the spinner pieces are the same size. So it's the same chance of it landing on 1, 2, 3, 4, 5, 6, 7, 8, 9, or 10. Okay? That's all it means. So we have to decide first, when we have OR, which of these formulas uses OR? The top two with the U's or the bottom two with the A's? The top two with the U's, because the U means OR, right? So in order to figure any of these out, I have to decide, because I want to use one of these formulas to do this, is it mutually exclusive or not? Why? So what we have to decide, no, for this one here, we want an even number or a factor of 3. What are the even numbers between 1 and 10? 2, 4, 6, 8, or 10. What are the factors of 3? 1 and 3. Do they overlap? No. If they don't overlap, what are these? Mutually exclusive. Okay? So when they're mutually exclusive, you just take the two probabilities and add them. So probability of an even number plus the probability of a factor of 3. So even numbers, 5 out of how many? 10, because 1 to 10, right? Plus factors of 3, 2 out of 10, which equals 7 out of 10. So before we do the question, whenever there's an OR, we have to decide, is it mutually exclusive or not? If it's mutually exclusive, you just add the two probabilities. If it's not mutually exclusive, you add the two probabilities, but then you subtract off the overlap. Okay, because you're counting it twice, which is a problem. So we'll do B together. On an odd number, what are the odd numbers? 1, 3, 5, 7, 9. Stop, because it's numbers 1 to 10. Multiple of 3. 3, 6, 9. Mutually exclusive or not? Not mutually exclusive. So I have to add up their two probabilities and then subtract off the overlap. So I'm going to do probability of an odd number plus the probability of a multiple of 3. Subtract off the odd numbers and multiples of 3. Why do we have to subtract it off? Because we counted the odd and multiples of 3 here, and we counted the odd and multiples of 3 here. So we counted it twice. So we take it back off once so that we don't actually have too much, counting it too many times. So what's the probability of an odd number? 5 out of 10. Multiples of 3? 3 out of 10. What's our problem right now if we put this answer? We've counted what? 3 and 9 how many times? Twice. Can we count them twice? No, so we have to take them back off once. So how many of them are overlapped? How many odd multiples of 3 are there? 2. So we subtract off 2 out of 10. So we get 6 out of 10 or 3 out of 5. Okay? You're going to try C. A divisor of 15 is a number that divides evenly into 15. So like 3 is a divisor of 15. Or 5 is a divisor of 15. They divide evenly. So when you divide that number into 15, you don't get a decimal. Okay? So try this out. You first decide are they mutually exclusive or not because of the or. Okay, a number less than 8. Does it say less than or equal to? It says less than. So 1, 2, 3, 4, 5, 6, 7. A divisor of 15. 1, 3, 5. That's it. Right? Overlap or no overlap? Are any of these numbers overlapping? Yeah, actually all 3 of them are, right? So it's not mutually exclusive. So I have to do probability of less than 8 plus the probability of a divisor of 15 and then subtract off the overlap. Less than 8 and a divisor of 15. So less than 8 is 7 out of 10. Divisors of 15, 3 out of 10. And then I have to subtract off 3 out of 10, which actually takes all those ones back off. But the reason why it takes all those ones back off is we counted every single one of the divisors of 15 in the less than 7s, right? So it's 7 out of 10. This one says, in a particular class, the probability that a student has a home video game system, the probability of a gaming system, is 0.62. In the same class, the probability that a student will have a video system and a TV, gaming and a TV, is 0.46. Determine the probability to the nearest hundredth that a student in the class has a TV. So the only reason why this works is it says independent, and I'm just showing it to you early, but we haven't dealt with independent yet. Independent is actually this formula here. Independent and dependent. These events are independent of each other. So if it says independent, we have to use the independent formula. So I'm just showing it to you now, but it's next lesson, okay? So you have to make sure you read thoroughly. So you would have the independent formulas P of A and B equals P of A times P of B. You guys know that already. What does and mean? Multiplication, correct? So when we have and, we can always multiply. So we have G and T. So instead of A and B, we have G and T. So 0.46 would equal 0.62 times P of T. We don't know what it is. How could we get P of T by itself? 5 by 0.62. So P of T equals what? Okay. I'm just showing this to you so that you don't just always think, hey, we just use the top two formulas when it has two probabilities or something, okay? You have to read and see what they say. When you've done that, flip over. You can try the question at the top of the next page. Always write down your knowns, the known values you have. We have probability that Eric will play golf this weekend is 0.5. So probability Eric will play golf, it's a G, 0.5. The probability he will play tennis is 0.3. Probability he will do neither is 0.25. Ooh, the heck. Probability he will do neither tennis or, so we could go tennis or golf, neither, is 0.25. We need to figure out what the overlap is. How do we figure out overlap when I give you neither and the two separate events? What did we do when it was set theory? We added them all up and subtracted them from the total, correct? In this case, our total is 1. So we're going to go 1 minus 0, we'll go 0 0.5, 0 0.3, 0 0.25, which is 1.05. Subtract 1 and you get what? 0.05 overlap. So let's draw out our Venn diagram. So here we have 0.05. Here we have 0.25. How do we get these two separately? Subtract, right? 0.5 minus 0.05 is 0.45. 0.3 minus 0.05 is 0.25. So now, the probability that he will do at least one of these activities, at least one, means one or more. So basically, did I have to figure it all out? No, I could go 1 minus the fact that he did none of them, and it's 0.75. But now I could actually add these up, and it's 0.75 either way, right? The probability to the nearest hundredth that he will play tennis and play golf, 0.05. Once you have the Venn diagram done, it's really easy to do the rest. You just answer the stuff. So it's going to be 0.05. Okay? In a group of 80 elementary school children, so we're looking at 80 kids, 48 like cornflakes, 22 like both cornflakes and oatmeal, 20 children like neither. Bless you. So did we do probabilities yet? Right now, are those numbers in probability form? How could I get them in probability form? You just have to divide them by the total. What's the total? 80. So if I want the probability of liking cornflakes, I'd go 48 divided by 80. And what is that reduced to? What's 48 divided by 80 reduced to? Pardon? 0.6? Did you keep going? Okay, 3 over 5. So I will take both right now because the decimal actually stopped. If the decimal kept going, you can't round until the very last step, correct? You'd have to keep a fraction then. Now let's fill out the rest. Probability they liked cornflakes and oatmeal. Probability cornflakes and oatmeal would be 22 out of 80. So what's that? What's 22 divided by 80? And that's not rounded, right? So we're okay. Then, neither children liked cornflakes. The probability of neither would be 20 out of 80, bless you, which is 0.25. What could we do now to make this represented better, easier? What could we represent it as? Venn diagram. Cornflakes, oatmeal. What could we put where now? What do we have to start at? Oh, there's two places we could start. We start in the middle, 0.275. We could also write outside, which is 0.25, because that doesn't affect my circles. Then what can I do? Go 0.6 minus 0.275, and what do you get? 0. How could we get just the oatmeal? Subtract all three of those from 1. .15. So the probability to the nearest hundredth that a child selected at random from the group liked only oatmeal is how many? 0.15. Does it make sense how you work through it? Now you could have done the Venn diagram completely with just numbers and not probabilities. The Venn diagram would have to add to 80. You'd get whatever your number is in just the oatmeal, but you'd have to remember to take that answer and divide it by 80 to get your percent. So either, or you get your decimal. Either way would work. I like just dealing with probabilities right off the bat so I don't forget to not divide at the end. And you'll note that you didn't divide because it says to the nearest hundredth. Well, your answer would be 15% of 80, which isn't 100. So that would be a problem. Thank you. All right. You try this one. Well, then next. Yeah, just this one. Example 6. A travel agency has 100 people, surveyed 100 people to determine if it's cycle or ski. The key thing, the reason why I turn it into percents is when it says this, what is the probability? The moment it says what is the probability, I turn into decimals or percents, right? Because in the end, you're going to have to give a decimal or percent, something over a total. The total is 100. So I need to start off with the and, so it's going to be 0.17. Because 17 divided by 100 is 0.17. 100 is the best thing ever. It just moves the decimal place. Then I can go to ski. Ski, so this would be 17 out of 100, which is 0.17. 29 out of 100, which equals 0.29. 68 out of 100, 0.68. Now, if you did them just as the numbers, not a big deal. Just take your answer at the end, divide by 100, right? Not a big deal. So, S, 0.29 minus 0.17 is 0.12. C, 0.68 minus 0.17 is 0.51. How many are on the outside? 0.20. How did I get that? 1 minus everything else, right? Because the probability adds up to 1, or if you change it to percent, it adds up to 100, or if you left it as numbers, they add up to 100, right? So it says here, what is the probability? I'm going to say to the nearest percent. That a randomly chosen individual from the above group of 10 or of 100, I don't know why I'm with 10, cycles only. So cycling only is 0.51, right? I just connected her phone. 0.51. But is that my answer? No, I said to the nearest percent. So what is that? 51. Okay. We're going to look at the next one. Dominic and Laura are playing a board game. To move a turn, Dominic must roll either doubles or a sum of 7. The moment you roll 2 dice, you need to find a way to list all the outcomes without missing 1 or 5. Okay? So when you roll 2 die, the easiest way is to actually roll, to lay out what you roll. So along the top here is I'm going to put the outcomes from 1 dice. 1, 2, 3, 4, 5, 6. On the side here, I'm going to do an array, and I'm going to put the outcomes of the other dice. 1, 2, 3, 4, 5, 6. These are the outcomes I could possibly have, correct? This is like when you used to make those times table charts. You ever did that? I hope you did. So on the middle, I'm going to change my color so that you can easily see what I'm doing. Now, those are going to be all the different outcomes I could get from the 2 dice, right? One die has the numbers 1 to 6. The other die has the numbers 1 to 6. And I'm going to list all the possible outcomes I could have from the 2 die. So in the first one, I would have 1, 1. The next one, I'd have 1, 2. I'm listing the top one second. Then 1, 3. Then 1, 4. Then 1, 5. Then 1, 6. This represents like the first die I would roll a 1 and the second die I'd roll a 1. The first die I'd roll a 1, the second one I'd roll a 2. So I'm listing all the possible outcomes. Just like when we did heads and tails, we did a tree diagram. When you do 2 dice, you have to do an array like this. Okay? So then it would be 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6, 3, 1, 3, 2. Okay? We agree? Now, we've listed all of the different outcomes we could possibly have, correct? Now they want us to list Dominic must roll either a double or a sum of 7. So what I'm going to do is circle all the ones that are doubles. Okay? How many are doubles? 1, 2, 3, 4, 5, 6. So probability of doubles is 6 out of, how many of them are there? 6 by 6, so 36. So I have a 1 in 6 chance of rolling a double, right? Then we need to look at the sums of 7. Right. Then we need to do the sums of 7. This one here, this one here, this one here, this one here. These would sum to 7. How many of those are there? 6 out of 36 or 1 out of 6. Now it says or, so the formula I can use is either the top formula or the one below it, because they're both ors, right? They have the U symbol. What we need to check, though, is there overlap or not? If there's overlap, we have to subtract off the overlap. If there's not overlap, we just add the two. Are there any that overlap here? Are there any greens on top of blacks? Or blacks on top of greens? No. So there's no overlaps. This is actually mutually exclusive. And when it's mutually exclusive, you literally just add them. So we're going to get 1/6 plus 1/6 because or means add. We don't have to subtract off overlap because if we subtracted off overlap, what would overlap be? 0, right? So we're not going to subtract overlap off. So we get 2 out of 6 or 1 out of 3. Then look at the bottom of the page is your homework.